So we're going from we're going from rectangular to polar. So last time we went from polar to rectangular, so now we're going the other way. So solve for r in terms of theta. Once again, we've got the same x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tan theta equals y over x. So in this case, we see, oh, hey, that's nice. We've got r cosine theta, r sine theta, we've got y, we've got x. So we can just swap those out directly, right? We can swap them out for what we have here. So we swap them out. Y is r sine theta equals 2 times x is r cosine theta. So 2 times r cosine theta plus 3. So at this point, we were told to solve for r in terms of theta. So we need to get our r's on one side so we can get just r by itself. So we move the 2r cosine theta over by subtracting it. So we've got r sine theta, now minus 2r cosine theta from both sides, equals positive 3 is still left over here. Now notice we've got an r here and an r here, so we can use the distributive property in reverse. We pull that r out, and we've got sine theta minus 2 cosine theta equals 3. We now divide that out, so we have just r. So r equals 3 over sine theta minus 2 cosine theta. That might be a little surprising. That seems like a fairly complicated thing if it's going to just give us a line, right? But some things, polar is better at graphing certain kinds of pictures, and rectangular is graphing other kinds of pictures. So it depends on the thing. Rectangular is great for graphing lines. Polar is not as great at graphing lines. And you might be surprised that that would even wind up coming out to be a line. Try plugging it into a graphing calculator, and you'll see that winds up giving us y equals 2x plus 3. It's just another way of graphing it. You might have a little bit of difficulty seeing why that winds up giving it. If you think about it, this bottom part here is going to sort of work as an asymptote as it approaches the same angle that this line is based on, which is why it's going to shoot off infinitely in both the top and the bottom. So think about that for a while. Try graphing it. Just in general, try to play around with graphing as many polar functions as you can. It will really give you such a great sense of how the stuff is working if you just play with it for a while on a graphing calculator. All right, we'll see you at Educator.com later. Bye.